Welcome back. Today we're going to talk about real numbers and the sets that they can be in. And so what we're going to do today is we're going to start to fill out this little chart here with some examples of numbers that would be real. I know you're thinking, well, what's a real number? Aren't they all real? I can really write them. Okay, but there's some that are they're called imaginary numbers. We're not going to talk about those today. We're going to talk about real numbers and the categories that they fall into. They're basically two categories, rational and irrational, and you're going to see that I have this Venn diagram inside of the rational part because they're going to fall into integers and whole numbers, and we're going to go from the outside in, from the most broad to the least. Some examples of rational numbers. So I could have fractions that are improper, like a 27 over 4. As we have kind of talked about, we could also have repeating decimals. So 0.3 repeating is actually equal to 1/3 if you'll recall. So that even though it's a non-terminating decimal, it goes on and on and on, it is still a rational number. We can also have negative irrational numbers. So we could have -6/7, or we could have a straight decimal in like a 4.5. Moving a little bit farther in. So you'll notice I don't have any whole numbers or integers here. And if I'm talking about integers, I could have the negative whole numbers, because everything inside this big bubble of integers is contained therein. So what you're going to see is in this whole numbers, I could say like 1 or like the square root of 4, which I know to be equal to 2. And also like 0 falls in there. But all of these, 1, 2, and 0, those are integers as well. They just fall inside the category more specifically of whole numbers. Irrational numbers, as we talked about, we end up with crazy things like square root of 17, or maybe like pi, or square root of 2. So we end up with some things that are not even positive, so like negative square root of 11. So those things are irrational. They can't be written as a fraction or a whole number, or they're irrational. So what we do with this information now is we kind of look down here, and I'm going to leave this chart up to kind of help us. We're going to write all the names that apply to each number. And so when I look at these things, immediately I'm kind of seeing a couple square roots, I see a negative number, so I got to kind of keep in mind what I'm looking at here. In general, so I've got this square root of 5. Well, when we look at square root of 5, we know that the square root of 4 is 2. And we know that the square root of 9 is 3. Okay, so in between there, notice the square root of 5, it's not going to have a whole number part. It's going to be a non-terminating, non-repeating decimal. So the name that would apply to this would be irrational. Okay, so that's an irrational number, kind of like square root of 17. It goes on and on and on, but it doesn't have a terminating or repeating component. In B, we remember, of course, we've got these two decimal places, so really we could write this as -17 and 84 out of 100. Well, we know that that's not even in lowest terms, but I can write it as a fraction. And so this is going to be a rational number. In letter C, we see square root of 81 over 9. Well, let's do a little bit of doctoring up on this one, shall we? We know that 81 is one of those special things that we call a perfect square. Remember that? Because the square root of 81 is actually equal to 9. And when we have 9 on top and 9 on bottom, we can reduce that fraction to 1. Well, 1, notice that's up here in this whole number, so we want to name it as specifically as possible, but we're going to start from the outside, so it's rational. It is also an integer. And it's also a whole number. So it falls under all those categories when we're talking about whether it's a whole number, rational number, irrational. So in the real numbers, it's those three things. Okay? I want you to try these next two on your own. and see what you come up with, and we're going to talk about them in class. So a baseball player pitched 12 2/3 innings, and the length of the side of a square with an area of 10 square yards. I actually want to draw a picture of that for you. So we could think of it like this. It's a square, and the area equals 10 yards squared. And so the side lengths we don't know. So we could set it up as like area equals x squared. So is that one rational, irrational, whole, integer? What is it? Okay, thanks for watching, guys, and we'll see you next time.